Very good morning, my students. Let me start with the next session, boundary layer theory under the concept of flow through circular conduits. Next slide. So we all know that organization. This is the organization I'm going to follow. Introduction, history of boundary layer theory, boundary layer structure, boundary layer terms, boundary layer types, boundary layer theory application. In this video, possibly we will see up to boundary layer structure, fourth concept. Next slide. So in the introduction, Reynolds number already we have seen. So inertia force to the viscous force, the ratio is called as the Reynolds number. So the boundary layer theory is defined by the boundary as a layer of fluid developing in the flow with very high Reynolds number. So when the Reynolds number is high, the boundary layer theory has the meaning of steady. Otherwise, the boundary layer will be very minor, can be neglected. That is with the relatively low viscosity as compared with inertia force. So here the viscous force will be high compared to the inertia force. This theory was introduced by the early Prandtl, the scientist Prandtl, who invented this theory, that is boundary layer theory. This theory is helpful in application of science, technology, sports, in our livelihood. Everywhere we can apply this knowledge of Prandtl number or boundary layer theory in our everyday life. Next slide. So in August of 1904, Ludwig Prandtl, professor, University of Göttingen, presented a paper on boundary layer in Third International Mathematical Congress in Heidelberg. So that was the first innovation of boundary layer. So Prandtl was the first to realize that the relative magnitude of the inertia and viscous force. He first proposed the two-layer solution. He proposed the two-layer solution, which is having the thickness enabling concept. Next slide. So it is the locus of point, which is the velocity of point at which the fluid particles becomes equal to 0.99 of free stream velocity. Velocity of flow at boundary layer is 0. Velocity of boundary layer is 0. The velocity of flow will go and increase rapidly till at the extreme layer. So these are the concept he innovated in the boundary layer concept. The portion which is outside the boundary layer has a high value of Reynolds number because of the high velocity of flow. So these are the concept he invented during the boundary layer theory analysis. Next slide. So here we can see the fluid is there. When you hit a stone on this water flow, there will be rise of sudden water. So this is nothing but separation of one layer to another layer. Where we can see it is a turbulent. It's a turbulent flow. We can see the turbulent flow of the flow fluid. Certain level which is following the laminar flow. After that, which is following the transition region. It is following the transition region. There will be a certain rise of fluid flow that is called as turbulent. That means here the laminar flow during that period, the Reynolds number is low, where during the transition, the Reynolds number is in the transition region, or in the turbulent flow, the Reynolds number is high. Reynolds number is high. Both the cases I have elaborated the previous deliberation, that if the fluid is flowing through the pipe, what will be the Reynolds number? The fluid over the plate, what will be the Reynolds number? That I have elaborated. Next slide. The same diagram here, little bit about the five concept. That is nothing but buffer layer, viscous, turbulent region, and this is a turbulent region. A different diagram, that's all. This is the laminar diagram, laminar flow. This is the transition flow. This is a turbulent flow. Here u infinity is the stream velocity. Here is a top is the stream velocity. Here also stream velocity. Here which is constant at the initial stage u infinity is 0. Here it is developing, so it is having certain value. So let me see one by one, this concept one by one in the forthcoming slide. So here we can see the concept of laminar and turbulent in a different xy coordinate. So here the flow is steady. Here the flow is hither and thither, moving one place to another place with graphical movement. The viscous nature of airflow reduces the local velocities on a surface and is responsible for skin friction. On the basis of that boundary layer are further classified into two types: laminar boundary layer, turbulent boundary layer. Laminar and turbulent boundary layer. So with this, I would like to conclude the session. So we will continue in the next session.